Hi there, my name is Jacob Aldrew, and you're watching part 4 of Motogadget's multi-part series on how to install the mo.unit Blue and many of its accessories. In part 1, we covered your shopping list and other considerations that you should be looking into when buying a mo.unit Blue and a lot of its parts surrounding it. In part 2, we stripped down the motorcycle and got it ready for the install. In part 3, we took a detour, and instead of integrating it into the motorcycle's current wiring, we pulled you aside and showed you most, if not all, of the skills and tools required to install the mo.unit Blue. Okay, maybe not all the skills required, but definitely the foundational ones, so that now in these videos we can kind of breeze through it. When I make a connection or install a wire into the mo.unit, you already have mastered those skills and know how to do it because there was a separate video on it. We don't have to keep re-teaching in each video going forward. So in this part, in part 4, we are actually going to get into it. We're going to show you how the mo.unit works via a bench test. I'm going to show you where I left off in my wiring. Remember, we had that homework assignment of getting our wiring all ready to go. I'm going to show you what I did to get my wiring ready to go. Then we are going to do it. We're going to integrate the mo.unit into the current motorcycle's wiring harness. So we're not quite at the point of installing everything. We're not doing switches and gauges and lights. Those will all be in following videos. What we're going to be doing is really integrating the mo.unit into our current wiring harness so that we can forget about it. We can have the motorcycle running. We'll have the positive and negative cables connected. We'll have that 12-volt switch ignition connected. We can kind of move on from the charging system, from starting the motorcycle, and we can really just focus in on the mo.unit and just adding more and more cool accessories to it. So like I said, by the end of this video, we'll have the mo.unit integrated into the motorcycle's wiring harness. We'll be able to start up the motorcycle will charge the battery properly, we'll be good to go, and in the following videos we really just get to focus in on the mo.unit itself and all of its accessories surrounding it. Now, last time we saw each other in front of this motorcycle, we had some homework assignments on getting everything set up and ready to go, and I've also just been putzing around on this motorcycle a little bit. So let me get you up to speed with the changes I've made and where this motorcycle currently sits so that you're not thrown off. First off, I've installed a new battery just for the sake of having a nice new battery that's fresh and ready to go. The other one, I couldn't tell the age of it and just wanted a new one. Secondly, a new starter motor. That one was always giving me problems in the past. I gave it to a buddy, he's gonna rebuild it and use it for his bike, so I just slapped in a new one here. Now, while I've left all the necessary electronics for charging and ignition and the fuel system, because again, I want this motorcycle to run at the end of this video, I did remove the secondary air system. It's a common modification made on this motorcycle. You can choose to do it if you'd like or not. I've also removed the air intake system. It's just not necessary at this point in time, and it gives me a little bit more room to work around here. I've also removed the front brake system because I'm going to be rebuilding all of it, and I've polished the exhaust just for the sake of doing it. I've also slapped on a new set of handlebars. They're a little bit lower, sleeker. I like the black coating on them, and it's just a good fresh start for all the new controls. Lastly, as we talked about, I finished up all the wiring and have it ready for the mo.unit to install, but we'll get back to that in a minute. I've got a nice digital diagram for you to look at. For now, let's turn around, get to the bench, and we're gonna do a little bench test on the mo.unit Blue to show you how it works. At its core, this is how the Motogadget mo.unit Blue works. We have a battery that will supply it power. We have the mo.lock NFC, which will allow us to signal to the unit to turn on. We have the mo.switch that will allow us to send inputs to the Motogadget mo.unit Blue, and then we have the mo.disc, which is a turn signal, which will show us proof that the outputs actually work. So for this setup, what we're going to do is we're going to power it up, we're going to turn it on, and we're going to operate the turn signal. To start, we need to have power go from the battery to the mo.unit Blue. So to do that, we're going to take the positive power, this is the 12-volt positive lead from the battery, we're going to connect that, just lightly for now because we have to add some other things. And then we need a ground, and that is going to be the ground right here. That again, we're just going to connect loosely. We don't have the fuse in right now either, but now you can see that with this setup, the mo.unit is able to receive full 12-volt power. Now, we need to tell the unit when to turn on and when to turn off. And to do that, that is what the mo.lock NFC is for. We have 3 cables here. One is positive, one is negative, and one is the switch. This is one of the few inputs that's involved with positive power, but it is. So we are going to hook up the positive side of our mo.switch to the positive side right there. And now we need to connect ground. And then this switch here goes into the lock input, just like that. So now, if I am to connect the fuse, you can see it had some cool flashing lights. And now if I take the tag and run it across the top of our mo.lock NFC, the unit is now on. We do it again, and the unit turns off. But now we want to control something. We want to turn this turn signal on and off. How do we do that? Well, we start with the mo switch here. Now, I don't want you to think that this is complex because there's a few wires. We have a ground, we have a positive because these are lights, and then we have 2 signal wires because we have 2 buttons. But honestly, all this is doing is connecting from ground to the input side. It's really no different than the same signal that a continuity meter gets. There's no power there, it just recognizes that a circuit has been completed. So instead of this switch, what I'm going to do is just show you how it connects to ground. To do that, we're going to connect one end of our switch, if you will, to ground. You can see this is why we'd be using a frame ground in a lot of situations, because we do not need to be running every ground from the switches to this here. And now we connect the other side of our mo switch to the input we want. We have lock, start, turn left, turn right. Lock, start, turn left, turn right. So this here is going to act as our mo switch. When we touch these together, the mo unit input recognizes that it's been completed, and it then lets power come through the battery and out the outputs to our turn signal. So let's continue. Now we just have too many grounds on that side, so I'm going to use this side here of the mo unit. That still works as ground. And then the positive side connects to the turn right output. You can see we have our start here, we have turn left, and we have turn right. That gets plugged into that spot. So now what should happen is that when we use our NFC lock to tell the unit to turn on, it does just so. And if we were to be using our mo switch, we would just have to tap these together. And now suddenly, even though this is a momentary switch, it knows that you've signaled to have the mo unit run the turn signal. To stop the turn signal, we'd press the button again. Just like that. That's what makes the mo switches in this whole system so much more reliable than your old switches, because old switches often have the 12-volt power running through them, and that just wears them out. And this doesn't have that problem. This is just connecting to ground for just a moment. It feels that signal and it sends the power via the unit, not via the switch, to the turn signal. Now, a note about wire thicknesses. If you look at the mo unit manual, it shows you the wire thicknesses that they use for the mo unit coming out of it to its accessories. But you'll note that some of them are quite thick to the turn signals, when the turn signals themselves, if you use like the mo discs or something, have really thin wires. So where's the difference there? Well, the thicknesses that they show you in the mo unit manual are if you're going to use the maximum power that the mo unit can output to the turn signals and things like that. So if you want to play it safe, just use the wire thicknesses that the mo unit manual says. Those wires will be thick enough to handle as much power as the mo unit can give out. But if you want to run as thin of wires as possible while still being safe, you can follow Ohm's law. And Ohm's law is a way for you to be able to end up at a chart to show you the wire thicknesses that you can use. Here's how it works. You take the wattage of the end device, so let's say like a headlight, and let's say it's 24 watts for simple math for myself, divided by the volts, and that's going to be a 12-volt system, so we're going to be divided by 12. And that's going to get us the amp draw, which would be 2 amps. 24 divided by 12 is 2. So now that we know the amp draw required, we're going to measure the length of wire that we need, and we're going to take those two numbers and we can go to a wire thickness chart and we can figure out the thickness of wire that we can use. I would always play it safe here and go a little thicker than you need. There are many of these charts that you can find online. I would just say always err on the side of thicker wire than thinner. And again, if you don't want to do this math, just run the thickness of wires that the mo unit manual says. So we're about to install the mo unit blue, but I want to show you where my wiring left off. What are we about to integrate into? We have left the battery, the regulator, the rectifier, the ignition control unit, the ignition transmitter, the coils, the starter if I didn't say it already, and the stator. So everything involved in charging and the ignition. Everything else, the controls, comms, whatever you want to call them, everything else is gone. Now, I actually took my wiring diagram that was in the manual, and I've made it digital so that we can pop this up, and if this is a little bit easier for you to learn, we're gonna go off of this. So this is the original wiring diagram This is everything connected. So what does it look like after we removed everything? It looks like this. Now, yes, you see the oil, neutral, and brake switches in the top right, but we're gonna get back to those a little bit later in a following video when we're covering the gauges, switches, stuff like that. So for now, we're focusing down here. And this is everything that's left. And you'll see that every wire with a slash in it is a wire that was cut, and then every wire with an X over is a wire that we cut and we do not need to be using anymore. So these spots that we need to do something about are highlighted with yellow boxes here. That's the ground, a 12-volt switch, a start, and the blue wire that goes to the rectifier. Okay, so back to the real world. Here are our wires that we talked about. Let's start solving some of the things that don't involve the mo unit. That's mostly two different things. We have the brown green wire here coming out of the ignition control unit, and we need to ground this somewhere. For the time being, I'm just going to alligator clip this ground to the engine. That'll make for a ground right there. Obviously, we'll clean that up once we start getting going with the mo unit, but let's just make sure we're right, and we'll have that be grounded. Secondly, is on the inside of our coils here, we have this outside one with the black wires. We have the inside one with green. We've done a couple things. We have this green wire that was here originally, and this wire again leads to the ignition control unit up into that. And then we have the other green wire, and this is the one that we cut out of the wiring harness and marked 12-volt switched. And so we knew that this one has to go to the mo unit. So that one's gonna stay there. And then this green wire here, pull off, this is that aftermarket diode simulator. And so that gets plugged in. And now this green wire here and all these are all gonna be 12-volt switched once it receives power from the mo unit. This goes on to this inside terminal of the coils. That connects on like that. So we'll get back to this guy in a minute. But then this green aftermarket wire runs all the way down, almost out of screen here, to this diode board or to the rectifier and connects to that back terminal over there. So that should now energize the system to get it to charge via that green/blue wire. It's both colors when it meets with this little thing in the middle. And on the digital wiring diagram, that looks something like this. We've now connected that ground to the frame, and we've added this green-blue wire from 12-volt switched positive off of the coils to the diode board or the rectifier. And then see that blue wire that's crossed off? That one was initially right here in this connector. Now it just doesn't have anything there anymore, and that's totally fine. Okay, we have two more connection points that we need to solve, and those are going to involve the mo unit. That is the 12-volt switched power, and that is the power that will run to the starter or the starter solenoid to actually start the motorcycle up. But we're gonna pause on those two for a minute. We're gonna clean this up a little bit, actually connect ground and our big starter cable again, and get the mo unit installed. You can also see that in the meantime, I have now tacked on this little plate right here. I don't even know if this is gonna be a great spot. Honestly, all I know is it works well for camera, for you to be able to see what I'm doing. This is where in the part 2, I think it was, that we talked about mocking up a spot for you to put your mo unit. And you can do that with cardboard and some hot glue, or you can just take some cheapo MIG welder like I did and tack it up to the frame right here. That's what I've done. I can easily snap this off if I don't like the location. But the final result here, what this will be, again, I'm taking this all apart, rebuilding the motorcycle and doing it again for you guys here in a little bit. So hence the tacking. But what you'll want to do is have a steel plate that is welded nicely connected to the frame, so that acts as a ground as well, so that you're grounding the mo unit and its bolts and everything to the frame. Really, the game of grounds is just making sure everything's really strong, cohesive, that there's very little resistance between any of the ground. So nice thick weld across here would be how I do it. Again, check this location, make sure it doesn't have any tank interference, but right now it's facing the camera very nicely. So we're gonna mount up the mo unit right there. Okay. Okay, now that we have the mo unit mounted up here with this bolt on this side, we're gonna connect the battery positive and the ground cable to it. For the positive, we're gonna do this first. Not that it really matters in this scenario because I have no fuse in here. So no fuses in this, even when I connect from here, from the battery positive to the positive side of the mo unit, there's still no power running to it because I don't have a fuse involved. Still, let's be safe. We've got a live battery, it's full of power, we're connecting some cables, so let's not just let this, tap bare metal and everything while we're dealing with some real voltage here. So this ground spot here and the one on the other side are both through holes, so you can mount it onto a plate, but the positive, which says battery or BAT, is a threaded hole that is closed off. So we're gonna take the small little bolt that comes with it, and we're gonna connect that. But let's first connect to the battery positive. This is the fused cable that comes in the builder's pack, by the way. Nothing fancy happening over here, just removing the nut, slipping on the little ring, and tightening the nut back on. Again, if you don't put the fuse in it, because if you do and that touches, you're gonna be running 12 volt power, it's gonna get a little sparky on you. But we've got no fuse in it, still being safe, and there we go. Then we take the small bolt, and also still, you know, reference the mo.unit manual here because it says to add some thread locker, some medium strength thread locker to this little bolt here. Again, I'm in the mock-up phase, so no thread locker for me, but keep it in mind. Okay, that's positive connected. Again, no fuse. And now, oh, and that was, in the manual, it calls out a 6mm cross section for this wire. This is a 8-gauge cable here that came in the kit, which is a little thicker than a 6mm cross section. So we're playing it nice and safe there. But that is, again, this is 8-gauge fused, or you can do 6mm cross section. For the ground, it's a 1.5mm squared cross section. And that comes out to, I think, about 14 gauge if we err on the thicker side. For the ground cable, you can see I've just added some ring terminals. Again, reference part 3 on how to add these. I'm gonna add the big one to the battery and then the small one that matches the M5 bolt here to the ground. And we're gonna connect this straight to the battery just to have the cleanest ground possible. Okay. Ground is connected there. And to connect ground here, again, we're going to need the bolt and a nut on the back side. Pop that ground on and that through. I might have tightened this one too much. Now I am actually not going to put the nut on the backside quite yet because we've got to connect a couple more grounds to this. Now let's talk grounds. When we're adding all these ground cables, there's going to be a lot of them because this whole system is like ground controlled. You've got a couple options. One, you can find a spot on the frame and add like a threaded little rod that you have a nut that connects to, kind of like a battery terminal, and just have all the grounds be on like little rings on the end and connect it there. Or if you get the Ultimate Builders pack, it comes with this little ground extension that you'd mount right here. And now you've got like a ton of extra ground spots that you can pop into there. That's an option as well. You can connect to the battery if you'd like. There's lots of different ways. So don't be focusing too much on how I'm connecting my grounds. You can get creative with it. But for now, we're just going to keep connecting grounds to this bolt right here because it's easiest and I can verify that this is ground for you. So right now, if I was to put a fuse in this positive cable, we would get positive and negative power running to the mo.unit. But now we need to tell the mo.unit to turn on. So let's install the key switch that we're going to be using, which is the mo.lock NFC. Now you saw me do this at the beginning of the video, and it's going to be just the same. We've got the 3 cables here. Black goes to negative, red goes to positive, and the brown will go to lock, which is the lowest one right here. But let's first, let's connect positive first. There's negative, and then the brown wire goes to mo.lock right there. So now, again, to reiterate, we have got positive power and negative ground running to the mo.unit, and we've got a way to turn it on and off. There's no power because there's no fuse, but if I was to do this, the unit would turn on and off. Now, I'm not going to install the turn signal or turn signal switches or anything because that's just not the point we're at right now. We're trying to get the motorcycle to turn on. So now that we've got a way to turn the unit on, and we've got all the power connected, what we're gonna do is go back to these 2 wires that we need to connect with the mo.unit to finally fully integrate it. Pretty cool, we're almost there. So what we're gonna do is we're going to take our 12 volt switch and we're going to run it to one of these here. The 3rd label in, the 4th hole, is ignition. And that is gonna be our 12 volt switched. We pop that wire in right there. So now that ignition is like ignition on, right? So when we turn the unit on, it's gonna be able to run power to that 12 volt switch spot on our coils. And now I also want to get this thing to start, which means we need to, as I had before, remember how we turned on the turn signal by touching those 2 ground wires together? Well, the way you start this with the press of that button is no different. So we'll kind of hot wire up the 2 ground wires, one connected to ground, one in the switch, and we'll touch them together, and that will activate the starter solenoid to kick over the engine. But we need the power from the start spots to go to the starter solenoid, so it actually does it. So here is what I've built for that, because you see you have 2 spots for start, 1 and 2, and we're going to use both of them, and we need to connect them to the single terminal on the starter solenoid of this BMW. So what we've got here is these 2 wire ferrules on the end, and they come together onto these Spade terminals. And then I found this online. I just got lucky. I was buying some BMW parts and found that they had one of these guys just on one of the websites and grabbed this. So this is a double male to single female little connector. And we're gonna connect this to our starter solenoid. Let's connect our start wires here. One there, one there. So you can see right here, this is the starter, and you have this little terminal spot right there, and that's where we're going to connect on this little double connector that we've built. There we go, tight fit at the moment. We'll probably swap out this ignition wire for green so it's not all green, but we'll get to that later. Okay, now the last thing to do is we need to be able to press the start button to turn over the engine, and we're going to do that with a fake little switch. The next video will be about switches, so we'll cover all the switches and everything, but again, to make sure you just understand how simple these switches are, we're just going to use a piece of wire. You know what, why not? Let's add on our little ground board here, and I'll connect the switch to that. That's pretty cool. I actually like that a lot. This will probably exist in my final version. So now what every mo switch does is it connects one end to a ground and it connects the other end to the input. And you can see on the mo unit, again, if we head back to the wiring diagram, the start button is one up from the lock. We'll pop that in there. Now, when we touch these together, that will act as the starter. That's pressing the start button and it'll turn the engine over. But we need to tighten down our ground and then add the positive fuse. There we go. I've added so many ring terminals that I ran out of bolt length. I gotta swap it out. There we go. Now we really want to make sure that the positive side, anything over here on this positive, has no way to connect or jump to ground. So we're going to make sure that that is well insulated and that there's nothing connecting there or touching. I'm getting excited. We're just about to start up the motorcycle. So let's finally connect power to this unit. Watch all the lights light up. Okay. Did it do the lights? You'll have to tell me I didn't watch it. So this is the mo.lock NFC, and when I run this key past it, it should go green. Okay, it did it. So we are on, we are charged. Everything is up and running. At this point, if I just touch these wires together, that should turn over the engine. Now let's be smart here. If we're going to turn on an engine with all these crazy concoctions, let's make sure we know how to turn it off. We've got a few options, right? One is we can just tap this lock again and it'll turn everything off because we don't have a kill switch connected, remember? Secondly is we can pull out this 12-volt fuse. That will also kill it. We also have a fire extinguisher on standby, and we're going to open up the garage door to make sure we have some good ventilation through here. I think those are our precautions. What do we do if it catches on fire? And what do we do when we need to turn it off? If we've got those two things covered, let's go ahead and turn this on and connect the two wires. Okay, so we don't have any fuel in the system right now. So we are going to hopefully, when we touch those two wires together, turn over the motor, but it won't start up. There's no fuel in it. Or maybe there's a little, who knows? Maybe it will start up, but there's no gas tank connected, so it'll run out of gas pretty quickly. Awesome, okay, there we go. It took a second, that kind of scared me. There was like a millisecond where it didn't work. Is there always that little delay? I think so, right? Yep, cool. Yeah, nice little delay, so if you press it on accident, it doesn't kick over the starter motor immediately, kind of gives you a minute to make sure it's what you want to be doing. Awesome. Okay, let's get some fuel in this, see if we can turn on the motorcycle. We don't have any mufflers on, so it's going to be loud as heck, but it'll be a good time. Let's get some fuel. We also don't have any throttle cables attached, so I'm probably just going to have to reach near the carburetors and see if I can pull it up. And if you want to check to make sure that your motorcycle is charging, what you'll need to be doing is get the motorcycle running, then get it up to a good RPM, like, 4,000 RPM, and put a multimeter to your battery and make sure it's above 12.6 volts, 12.7, right? You want it to be in the 13 something range. So you can look in your own manual for what your motorcycle, where it starts charging in the RPM range and how much voltage should be charging. And that's how we'll make sure that we have the regulator, rectifier, the whole charging system still working with the mo unit. Also, because I have a tank going on, I'm going to need to extend these cables. So let me pop these ones off. And we're gonna make some longer ones. Okay, I guess it fits. Okay, we got our mo.lock turned on. Now, when we touch these wires together, let's see what we can do. Okay, full choke on both. Okay, let me take this off and we'll have a chat. Okay, I hope that you are at the same stage and as stoked in your garage as I am in mine. If something didn't work, if it didn't turn on, just go back through your wires. If I haven't shown you yet already, here's what kind of my wiring diagram looks like right now. We've got 10 things plugged in right here at the mo unit. That's it. If you can plug in 10 things, you can completely integrate this mo unit into your 1980s BMW Airhead and many other very similar motorcycles. So check your grounds, check your positive, make sure your battery is well charged, check everything out, make sure you've got it connected nicely. You can always use a multimeter to follow your wires, but if you've been kind of following the steps we've had in these videos, the reason we went so slow is to make sure you actually know what you're doing, and I'm not just here in video one going plug this in, and you don't know how it integrates into your own motorcycle. So hopefully before you even saw this video, you've got a pretty good understanding of what you were left with in your motorcycle. You've got this integrated and now your bike turns on. Now in part 5, we are going to get to all the mo switches. We're gonna do the mo switch LEDs that come pre-wired and the standard mo switches that you have to wire yourself. So we're gonna be spending a lot of time up here at the handlebars, getting them wired in and connected, and then we'll be running them through and connecting them to the inputs here on the mo unit. So your and my homework assignment until the next time we see each other in part 5 to work on the switches is to clean this up. Again, as I've stated before, I am going to take this all apart again, rebuild the motorcycle, weld this on, powder coat the whole thing, build a custom BMW, and then wire it all in really, really cleanly. So when we do that, there'll be some new, fresh aspects to look at. Maybe I get a new regulator rectifier, we'll see. I'll probably be restoring a lot of the wires that we have to keep, swapping out these crusty starter cables and all that. But this first section of the series, I wanted to show you how you could do this to your stock motorcycle. But what that means is that my setup isn't going to be as clean as yours is until we come back together when I have the full fresh build. But I will be cleaning up these wires just so they're easier to look at and easier to understand. For your case, same thing. Make it nice and clean. If you've locked in your spot and you love where your mo unit is mounted, finish up welding instead of just having little tack welds. Run the wires where you want and kind of start getting things lined up and cleaned up until we get to the switches. I would highly suggest you watch these videos in tandem with reading the mo unit manual that Motogadget has online. You can use it to read ahead, to go back, to double check your work. It's great to have for all the wire thicknesses and everything else, and if you're just someone who learns better from reading. And of course, if you haven't grabbed your mo unit or all the wiring or accessories, you can go to motogadget.com or motogadget.us. Until we see each other next, you can always find us on Instagram, TikTok, YouTube for short, faster content. We'll see you in the next video.